Imagine you're peering into the vast, cold emptiness of space. Suddenly you spot a tiny speck of light far away. It's not a star. It's not a distant galaxy. It's a planet, no, even smaller than that. It's a dwarf planet quietly orbiting in the asteroid belt between Mars and Jupiter. Its name? Ceres. Ceres may not be a household name like Mars or Jupiter, but it's full of surprises. In 2015, something strange caught the attention of scientists. NASA's Dawn spacecraft was on a mission to explore this little world, and it sent back images that shocked the scientific community. There, right on the surface of Ceres, were mysterious bright spots, glowing, shimmering, and out of place. These lights weren't just small reflections. They were intense, concentrated, and appeared to come from inside craters. The biggest one? Inside a massive crater named a crater. At first glance, you might think they're camera glitches or reflections from the sun. But NASA ruled that out. These lights were real. And they weren't going away. As dawn got closer to Ceres, the images became clearer. The lights weren't random, they had structure, patterns, and they didn't match anything seen on other celestial bodies before. Scientists were baffled. What could be causing these lights? Were they ice, salt, crystals? Or could they be something even more mysterious? This wasn't just a matter of curiosity, it was a major scientific puzzle. And the whole world was watching. The Dawn mission had already made history. It was the first spacecraft to orbit two extraterrestrial targets, Vesta and then Ceres. Launched in 2007, it spent years traveling through the solar system. After visiting Vesta, it made its way to Ceres in 2015. What it found there was beyond anyone's expectations. The Achater crater, which hosts the most prominent lights, is about 92 kilometers wide. That's roughly the size of a large city. Inside, at the very center, lies a bright, dome-shaped structure surrounded by shiny deposits. These lights are so reflective that they stand out sharply against Ceres' otherwise dark surface. NASA scientists began to dig deeper. They used Dawn's instruments to analyze the composition of the bright areas. The results were surprising. These spots were made of sodium carbonate, a type of salt. It's the same stuff you'd find in some cleaning products on Earth. But on Ceres it told a different story. Sodium carbonate doesn't just appear on the surface. It has to come from somewhere beneath. This pointed to the existence of underground briny water, liquid, salty water hidden under the surface of this cold dwarf planet. It was a clue that Ceres might be more active than anyone imagined. The implications were huge. If there's water beneath Ceres' surface, could there also be life? Maybe not complex life like humans, but microbial life? Extremophiles, tiny organisms that survive in harsh environments, might find a home in these underground reservoirs. This changed the way scientists looked at Ceres. It wasn't just a dead rock floating in space. It was a dynamic world with geological activity. Something beneath the surface was pushing salty water upward, leaving behind these glowing mineral deposits as it evaporated. The lights inside Achater crater aren't just sitting there. Some are spread in streaks. Others form spots in clusters. Some areas seem fresher than others, suggesting the process that created them might still be happening today. Ceres might not be done yet, it could still be changing. To confirm these ideas, scientists used Dawn's infrared spectrometer to look for heat signatures. And yes, some of the bright spots were slightly warmer than their surroundings. That supported the idea of recent or even ongoing activity. A dwarf planet, still alive in a way. This discovery sparked debates. If Ceres has a subsurface ocean, what keeps it from freezing solid? It's too far from the sun to stay warm naturally. But there might be other sources of heat, like radioactive elements in its core or chemical reactions between minerals and water. This means Ceres isn't just a relic of the early solar system, it's a chemically active world. And chemical activity is a key ingredient for life. Combine that with liquid water and salts, and you get something close to the basic requirements for biology. Even the location of Ceres is interesting. It lies within the asteroid belt, a region once thought to be too unstable for planets to form. Yet here's Ceres, round, layered, and possibly with a salty ocean beneath its crust. It stands out like a pearl among rubble. In recent years, scientists began comparing Ceres to other icy bodies in the solar system. Europa and Enceladus, moons of Jupiter and Saturn, are also believed to have subsurface oceans. They've been top candidates in the search for extraterrestrial life. But now Ceres joins that list. Back on Earth, researchers tried to replicate the conditions on Ceres in the lab. They simulated salty brines under low-pressure environments to see how they behaved. They found that brine can indeed migrate through cracks, especially if the crust is fractured by impacts. That could explain how water reaches the surface. An asteroid strike might crack the outer shell, letting briny water seep upward. Once exposed to space, the water evaporates, leaving behind glowing salt deposits. It's a cosmic version of a salt flat. But here's another twist. Some scientists noticed that Ceres' bright spots weren't completely still over time. There were small changes in brightness. Could this mean the surface was being renewed? Or that new material was emerging from below? It added another layer of mystery. Even now, long after the Dawn spacecraft ended its mission in 2018, data from Ceres continues to surprise scientists. The final orbits brought the spacecraft just 35 kilometers above the surface, closer than ever before. This gave us ultra-high-resolution images of the lights. These close-ups revealed fine details, cracks, ridges, and dome-like features. The central dome in a crater, known as Cerealia Facula, looks like it formed from a plume or eruption. That implies that the salty water didn't just ooze out, it might have erupted like a mini volcano. This type of cryovolcanism, where ice and brine erupt instead of lava, is rare but fascinating. It means Ceres may have icy volcanoes. Not fiery ones like on Earth, but cold ones that still reshape the surface. In fact, scientists believe this cryovolcanic activity could be part of a cycle. Heat from the interior causes brine to rise. It erupts or leaks onto the surface. The water evaporates and salt stays behind. Over time, new eruptions refresh the bright spots. The age of these spots is also a clue. Some appear to be only a few million years old, a blink in geological time. That means this activity didn't just happen in the ancient past. It might still be occurring today under our noses, or rather, under our telescopes. And while no life has been found on Ceres, its conditions make it a strong candidate for future missions. A lander could drill into the crust or sample the salts directly. It could search for organic molecules, which are the building blocks of life. NASA is already discussing potential future missions to Ceres. These could involve orbiters, landers, or even sample return missions. The goal? To dig deeper, literally, and uncover the secrets buried beneath its salty, glowing crust. And it's not just NASA. Other space agencies are taking interest. The European Space Agency and private companies may join the hunt. Because Ceres offers something rare, a nearby world with the ingredients for life, wrapped in mystery and glowing in the dark. Beyond science, Ceres stirs the imagination. In a solar system full of giant gas planets and rocky deserts, here is a world with shimmering lights and hidden oceans. Feels like something out of science fiction. But it's very real. Even its name fits perfectly. Ceres is named after the Roman goddess of agriculture and fertility. In a poetic way, it's a planet that might one day grow something, maybe knowledge, maybe life, or maybe just hope. Looking back, the discovery of Ceres' bright spots was a turning point. It reminded us that even the smallest worlds can hold big surprises. And that exploration still holds wonder. There's still magic in looking up at the stars and wondering what's out there. The lights on Ceres aren't alien cities. They're not signals from another world. But they are a kind of message. A reminder that the universe is vast, complex, and full of hidden beauty. And sometimes that beauty shines brightest in the darkest places. So the next time you look up at the night sky, think of that little dot between Mars and Jupiter. Think of the salt shining on a frozen crater. And remember, there's always more to discover. Always more to learn. Ceres is just one stop on a journey that has only just begun.